Hey guys, welcome to Empty Stack, and you're watching Leetcode series of problem solving using Java. And today we are going to look at a very famous problem, twosome. To solve this question, you should have knowledge on arrays and hash table. The difficulty level of this problem is easy, and it is asked in multiple companies like Facebook, Apple, Amazon, etc. Okay, so let's jump into the problem. Given an array of integers nums and an integer target, return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So a few things. The input is an array of integer and an integer target. Output should be the indices of the two numbers that adds up to this target number. There are two assumptions. One is that for every problem there is only one solution possible, and the same element cannot be used twice. Basically, an element sitting at one index cannot be used twice. An answer can be in any order. Let's look at few examples. 2, 7, 11, 15. The target number is 9. So output will be 0 and 1, because index 0 and index 1, 2 and 7 adds up to 9. It could be 1 and 0 as well. That is also fine, because the order is not important. Same way, 3 to 4, target number is 6, so index 1 and index 2 is the answers. And then last example, 3 and 3, target is 6, so 0 and 1, so both elements in this array adds up to 6. Okay, cool. Let's discuss the possible solutions. Approach 1, brute force. So if we iterate over the array and we try to find every element pair in the array and see if their sum is equal to the target value, we can find the solution. So if we start from, let's say, the first two elements 3 and 5, if their sum is equal to target, if not, we go to 3 and 7, then we go to 3 and 8, then we go to 5 and 7, then we go to 5 and 8, then we go to 7 and 8. Ultimately, we'll find the solution this way. Okay, if you try to write the code for this, algorithm is straightforward. We'll use two for loops. The first loop for the first element in the pair, the second for loop for the second element in the pair. For the first element, we need to have 3, 5 and 7, so we'll iterate from 0 to n minus 1. N is the length. And in the second for loop, we start from 5, 7 and 8, so that is I plus 1. Then we go to up to nth element. Okay, and at every iteration, what we'll do, we try to sum them and try to compare it with the target. If it is found, if it is equal, then we'll return from there. If not, then we'll continue this process unless we find the element. Okay, the logic is straightforward, but the complexity is high because there is a nested for loop. The complexity will be n square. This complexity can be improved if we use a data structure called hash map. Now, hash map can be very advantageous in this example for two reasons. Firstly, the read complexity from a hash map is O1. So if we use key as an element and value as an indexes, once we have found the pair, we can directly get the indexes of those pair using hash map and O1 complexity. Secondly, if at every iteration we keep on storing the elements in the hash map, we can search for their counter pair in the hash map. So for example, if 3 is stored, we can check, before storing 3, we can check if 12 is already present. If 12 is present, that itself means that we have encountered 12 in past, and that means 12 and 3 are the potential pairs, which add up to the target 15. Okay, let's look at the algo to understand this better. So we start from 0 to n. Okay, at every step, we check if the value of the target minus array is already present in the map or not. So for the first iteration 3, we'll check if 12 is already present. Currently the map is empty, so nothing to do. We'll go to else and we'll put the value 3 and its corresponding index to the map. Okay, next we go to 5. We try to look for 10. Now 10 is also not found in the hash map so far, so we will go to else and we'll put the value 5 in the index. Next we go to 7. Same way, we'll try to search for 8 in the hash map. 8 is not found. We'll put 7 and the index. Now once we reach 8, the target minus array will give us 7. Now 7 is found in the hash map, so this if condition will become true, and now we can directly return the indexes. What are the indexes? For 8, the current value of I itself is the index of 8. For 7, we can use map.get for the same 7, and we can get the index 2. Doing it this way, we can achieve the same thing in a single for loop, thus reducing the complexity to O(n). Let's look at the Java solution. Let's look at this function. We need to return the integer array which will have the two indexes. The input argument is the nums array and the target number. To return, we will create an integer array of size 2 and call it result. We'll return this result. Now we can define the hash map. The hash map will be integer type for element and index. Now we can iterate over the array nums from 0 to n, and then we can, in each of this iteration, we want to put the element in the hash map. So we can define that nums I comma I. The last step would be to check if the sum is equals to target. For that we discussed, if the target minus nums I is already present in the hash map, we can return from there. So we'll add that condition. Map.contains key target minus nums I is present, then we are good. We can assign the I and target minus nums I value from the map to the result 0 and result 1. Okay, and then we can return directly from here.